Hi guys, more integration fun today. Let's start by integrating this function here. So I've got x cubed over 3 minus 5 over 2 x squared plus 4x between 1 and 4, and that should give me 64 over 3 minus 5 over 2 times 16 plus 4x plus 16 minus 6 over 3 minus 5 over 6 over 3, 1 over 3 minus 5 over 2 plus 4, and altogether that comes to minus 4.5. Now, that's a negative answer, but when I think about my earlier description of an integration can be used to represent the area under a graph, what does that mean when it's negative? Well, if we look at this graph here, you can see the area that we're interested in between these two limits of 1 and 4 is underneath the x-axis. So probably my description last time of an area under a graph wasn't quite correct. And in fact, integration gives us the area between the x-axis and a graph. And area isn't a vector quantity. It doesn't have a positive or negative because it's built up basically from squaring some units or timesing two things together. It can't actually be negative, so area is always a positive. So the answer to this, the area between y equals x squared minus 5x plus 4 and the x-axis and again use the word between 1 and 4 is 4.5 square units. Okay, so if the area is underneath the x-axis, which it is on this one, we simply need to change the area to a positive. So area cannot be negative. That's the key thing. Now if I was to have a look at this next graph, which is y equals x cubed minus 5x squared plus 2x plus 8, you can see that there are two areas bounded by the x-axis, one between minus 1 and 2 and one between 2 and 4. So if I was to do this integration here, if I was to do it all in one go, so the integration between minus 1 and 4, I get an answer of 10 and 5/12. But if I was to integrate between minus 1 and 2, I get an answer of 15 and 3/4. And if I was to integrate between 2 and 4, I get an answer of minus 16 1/3. Sorry, 16 over 3. So you can see what's happened is that this, which is, I'll make it a bit clearer, minus 5 1/3. So you can see what's happened is that this positive area has added to the negative area to give us 10 and 5/12. But that isn't the correct answer. Remember, area cannot be negative. So this area here is actually 5 1/3 units, square units. So the actual area is 15 3/4. Add 5 1/3. And that gives me, so I've got 9/12 here and 4/12, so that's 13/12. So I've got 21 1/12 square units. So you have to look at the graph, because this one isn't correct. And it's not correct because it doesn't take into account the idea that area is positive. It will just add together the areas, the positive and negative areas that come out from the mechanical integration, add together to give this. But actually, the area, because we have to make that into a positive, because you can't have a negative area, you add the two together to get that. So often it can't be done in one go, and you have to separate into 2 or more separate areas, find the integration of each, and then add the positive values of all of those together to give you the answer for the area bound by the curve and the x-axis. Okay, so just a quick summary. You cannot have a negative area. If your integration comes out negative, you make that positive, and that's your answer. You have to be really wary of a graph that has positive and negative sections, or sections above and below the x-axis. You have to make them all positive and add them together. So you have to do it in sections. You can't just do it all in one go. Okay, thank you.